Hello guys, I'm a teacher Limboka Nsajuga Masami. Welcome to Limboka Physics. We have a question below states that an object with a weight of 50 Newton attached to the free end of the light strings roped around a wheel of radius 0.25 meter and a mass 3 kg. The wheel is solid disk free to rotate about in a vertical plane about the horizontal axis passing through its center. The suspended object is released 6 meters above the floor. Part A determines the tensions in the string, the acceleration of the object, and the speed with which the object hits the floor. Part B, verify your last answer by using the principle of conservation of energy to find the speed with which the object hits the floor. Let us consider these two diagrams here. The Part B diagrams, body diagrams with vector. It is important to understand the scenario of the question. We have flying wheel here as a larger disk of radius r that rotates about its axis z to z dash clockwise directions, and stripe angular displacement theta is also a displacement, the displacement which is linear displacement from an arc where the angular displacement swept. Okay, this is the strings that are passing through this flying wheel attached to the hang mass, this hang weight W, and we define W is equal to mass times G, and at this point it is initial conditions where we have a coordinate 0, s, and at this point is final condition where we have coordinate 0, 0. As you can see, the quantities that is at this final conditions here and the quantities that are in the initial condition here. Okay. These strings give us a tension, give us the force that is passing through its atoms or its atoms of the given material of the strings. These forces are called tensions, and depending on the elastic potential energy that is stored in this string. Let us look a tension with a red. That tension with the red is the one that is caused by the weight of this a block, and it is acting downwards as the block pulling this string downward, while this mass of the disk and axis, according to the strength of the attached place, cause another counterbalancing force with this weight, which it is in black directions. This force is tension in the black directions, and it is moving upwards. It's the one that produced by this disk. It's just like a normal force that is counterbalancing this weight, and this weight that is equal and opposite to this tension in red. Also, this counterbalancing tension, it is equal in magnitude and opposite in direction with this weight. Okay, so the directions of this system is in negative direction, in negative sense, because it is moving downwards in y axis, and also this tension in red, it will provide us a necessary source of torque here. This is a source of torque, as these tensions as a result of weight that act tangent to the perpendicular to the radius of this disk from the center of this disk, that the axis of rotations passing axis z to z dash. This will give us the product of this tension to this r will give us the torque necessary to cause a rotations. That is torque passing through this axis z to z dash. Therefore, let us consider the wheel to string part first. The wheel to string parts, we can get the relationship of this torque with the net torque, with sum of torques, by considering the Newton's second laws of rotations that give us a relationship of torque with net torque as from the center 0, 0. When we consider the sum of torque here, we must add clockwise and anti-clockwise torque, which is equal to net torque. On the side of anti-clockwise, we don't have any torque here, therefore it is 0. While in clockwise, we have torque, which is negative to indicate it is clockwise, r times z, tension T, which is equal to definitions of net torque from moment of inertia and angular acceleration, net angular acceleration. But this net angular acceleration is acting in clockwise also directions, because the direction of angular velocity is the same as directions of angular accelerations that passing through the z axis. Okay, Then we put in negative for angular accelerations, and this moment of inertia is the one that passes through the center of the axis of rotations, and we have the first equations. For the second case, that is this weight to string part, we will have tension that is moving up, and from the center of this mass that we indicated by this dotted line, we take this mass as a point from its center, as a particle at this from its center, difference from its center. But the direction is, as usual, it is in downward direction, negative sense. Therefore, we refer second Newton laws of linear motions. As you can see here, the tension is positive, the weight is negative, and net acceleration in y directions, it is negative. Then after doing the mathematics here, cancelling this negative, divide it on this either sides, we will have this equation 2. Then we are about to find the linear accelerations, as we have asked earlier, to calculate the linear acceleration. Now we must substitute this equation 1 by making subject t to this equation 2. Then we must multiply by r in both sides and let this negative terms in this left to this right. After passing equal sign become positive. Then we factor out the angular accelerations to get the formula for angular acceleration, which is finally, as you can see here or here. Then we relate this angular acceleration with linear accelerations by multiplying with radius r to angular accelerations. For multiplying with radius r, then we get the formula for a linear acceleration that is free from a radius. Remember, this is r square. We factor out this r square, and r square and r square is cancelled out, while this moment of inertia about the center of rotation of the disk is a half mass r square. We substitute this moment of inertia, then we factor out r square. We remain with this formula. We substitute this data from the that given from the question, then we will have the accelerations of this system as 7.7 meter per second square downwards. For tensions, we must refer the equation 2, and we make the subject for tension, and then we substitute the data that we've given, and we get the tension as 11.5 Newton. For the speed from the Newton, from the equations of linear motion, the third equation of linear motions, the equation of velocity, and with acceleration and displacement. Remember that our initial condition is displacement is s, and our final condition displacement is 0. But for acceleration here, it is 0 and v. Okay. For displacement, remember it is negative, and for displacement, remember it is negative, and the acceleration it's going down, also it's negative. Therefore, here we will have negative and negative cancel out. Our velocity now is equal to 9.61 meter per second. Thanks for watching. Please like, share, comment. Don't forget to subscribe to this YouTube channel for more video like this one. And wait for what next? Let us wait for a part B. Thank you.